Hey, welcome back. It is a beautiful morning here at my house, and today we are going to be looking at how to represent a multiplication equation using an array model. So we've dabbled a little bit with this with math warm-up, and I think once you see it, you'll remember doing that. This is just another trick to put in your bag of tricks on how to figure out the answer to a multiplication problem. So sit back and get ready to dig deeper into multiplication this morning. All right, in our last video, we learned that the multiplication symbol means groups of. So when we read this, we have 5 groups of 3. So you've already learned the groups of model, you've learned repeated addition, and you've learned the number line or skip counting method. So today we're going to learn arrays. So I'm still going to read this 5 groups of 3, but I'm going to create a pattern or a square that will show 5 groups of 3. So I'm going to do 5 going down, 1, 2, 3, 4, 5, and I'm going to put 3 in each group. And you can see that when I get done, I have 1, 2, 3, 4, 5 groups of 3. I show that it's 5 groups of 3 because this number going down, there are 5 groups, and this number going across has 3 in each group. So I could count these if I needed to, or I could know that 5 times 3 is 15. Okay, let's do one more together. We have 3 groups of 4. So the first number tells me how many columns I'm going to have going down, and the second number tells me how many are going to be in each column. So let's do it together. So I have 3 groups of, and in each group I have 4. So in mine I have 3 going down, and I have 4 going across, and I could count the number that's in there, and it would be, say it with me, 12. So 3 groups of 4 equals 12. Okay, here's some problems to try on your own. Go ahead and make the array and come back to check. Okay, here are the answers. I've drawn X's just because they're fast, but you could draw whatever you wanted. You could draw hearts or stars or smiley faces, whatever made you happy. I hope that you got these right. We're going to look at one more thing before this video is over. It's going to be a short one today. Shh, I can hear you cheering from here. Okay, here we go for the second thing we're going to learn today. By the time we get done here, we are going to learn to demonstrate the commutative property of multiplication. I hope you're making that gesture where your hands are on top of each other in fists and you're trading places, because we learned that with the commutative property of addition. And remember, multiplication and addition are like cousins. So we're going to dig into that a little bit deeper on the next slide. Okay, we're going to do just a little bit of a review. So in the commutative property of addition, we learned that if we switch the add-ins, the sum was the same. It's really the same thing, the same concept in multiplication. So here's my factors, 5 times 3, and my product is 15. I've done a groups of model to show that I get the same answer. 5 groups of 3 is 15, just like 3 groups of 5 is 15. So the commutative property says that I can switch the factors, but my product is going to remain the same. Okay, so let's practice the commutative property with our array knowledge that we learned earlier. So I'm going to do 8 groups of 3. And if I use my commutative property, that would be the same as, equals means the same as. So 8 groups of 3 is the same as 3 groups of 8. So I'm going to do an array model, and I'm going to show both versions. I want you to look at the difference. Why don't you do it with me? So this one says 8 groups of 3, so I'm going to have 8 going down. 1, 2, 3, 4, 5, 6, 7, 8. 8 with 3 in each one. I'm going to beat you. Are you racing me? Okay, so 8 groups of 3. Over here, I'm going to do 3 groups of 8. So 3 going down and 8 in each group. 1, 2, 3, 4, 5, 6, 7, 8. Who's going to win? Is it going to be me or you? I have to talk and make X's at the same time, so I have a disadvantage. So obviously my dog just got in trouble. My daughter is yelling at him, so I'm going to pause for a little break and see what's going on. I'll be back with the rest of this video momentarily. Okay, it's your turn. Apparently the dog was eating Ava's snack, and that was the explosion. So, back to the video. It's your turn, and you need to do an array to represent the commutative property. So you have 4 groups of 7 is the same as 7 groups of 4. So pause the video, draw your arrays, and then I want to talk about how they look different. Okay, these are what your arrays should look like, and you'll notice we have one that's more horizontal because it's 4 groups of 7. I can circle the groups. Or this one is more what I would consider vertical because I have 7 groups of 4. So that's just the difference. So remember, the difference does matter, especially in word problems. If the word problem said that I had 4 boxes of crayons and there were 7 crayons in each box, then my picture would look like this. If my word problem said that there were 7 boxes of crayons and they only had 4 in each box, then my picture would look like this. Now, the answer will be the same, but the way you set your problem up, your equation would be different, and the difference matters. So pay attention to the words in the question. Okay, here I've represented the commutative property through a model. I want you to give me the number sentence that would go with it. So think about it. Here I have 2 groups of 3, so let's write that down. 2 groups of 3, and then I'm going to carry my equal sign is the same as 1, 2, 3, 3 groups of 2. Okay, one more example for you to try. I want the number equations that go with this commutative property, and then go ahead and come back to check. Okay, here's the answer. 3 groups of 4 is the same as 4 groups of 3. Okay, we've come to the end of this video, so it's time for the joke of the day. What do you get when you cross a fish and an elephant? Swimming trunks. Anyway, I will see you in class, and we will learn much more about multiplication. See you soon.